Okay, we can review. We were introduced to more class concepts. We talked about class private functions. We will implement them soon. We talked about class friend free functions and operator overloads. so one of the interesting things is that C++ is allowing us to create user-defined types like this bank account class that we've been working on in the lecture and treat them as like integers, right? Recall you can create integers and add them, and you can do the same thing with user-defined types as long as the code's written to handle this. In our case, we did write the code. We had a friend function that allows us to add two bank account classes. We also created the overload for the istream, which is the cin, and the cout ostream overloads. This in turn helps us simply say cout account, and it'll display whatever we want or what we've defined in the function. In this case, we just display balance. And for cin account, we can capture input and feed it into our class via the cin utility or overload, right? The code that we had to write to make this happen. Also, before we get introduced to more advanced class concepts, we had to go and talk about pointers. And that is important because pointers work like references. However, they have more flexibility. They allow you to reassign a pointer to point to different variables. You can use it, as I stated, to help us with inheritance and polymorphism. And you can also use it to create dynamic memory. We had simple examples of that. We had a simple example of dynamic memory by means, and I mean very basic simple example. My main goal was to show you that you create dynamic memory, you use the memory, and you release it. However, this piece right here is where it's troublesome. Like, how long is that memory going to be in use? And eventually it may cause what is known as memory leaks, right? So if we don't release the memory, or we can have a pointer create new memory and then another pointer point to that new memory. We delete the new memory, and then the other pointer still pointing to that memory, which is now invalid. So that is the case of a dangling pointer. So we have to be careful with that. C++ has created smart pointers, and in this class we use unique pointers because they are very simple to use. And we had example to create one with integer, and then we use it, and then we can also take its address. Also, it is very important to understand that when we create dynamic memory, not when we reference a variable or create dynamic memory, if we want the value the pointer is pointing to, meaning if it's pointing, for example, here to num2, and we want to get this value displayed, then we have to use the asterisk or the dereference operator, which will give us the value. If we want the value of the address, not the address of num2, then we use simply numPointer. If we want the address where our pointer was created, then we use reference operator num_pointer. Very important topics. We also discussed that with unique pointers, it can only have one reference. If we create a unique pointer and we want to move it into a container or a list like a vector, we have to use the special move function, which behind the scenes rearranges pointers for us, and we don't have to worry about anything like that. Okay, so this week we will cover more concepts in classes. We will cover inheritance, and we will cover polymorphism. Those are the last two building blocks in object-oriented programming. Recall the first one is encapsulation, followed by abstraction, followed by inheritance, and then polymorphism, right? So we'll dive into those topics this week, and we need to make sure that we had this pointer lecture to know that, right? So let me see here. Okay, so the readings, read the last half of chapter 11. That'll cover inheritance. Actually, we will not be able to cover polymorphism. So read the last part of chapter 11 for inheritance. And then, well, let me think here. Hold on. Yes, we will cover inheritance and polymorphism. So we will you will need to make sure you reach the last half of chapter 11, everything that covers inheritance. Also followed by chapter 15, virtual functions and polymorphism. Please make sure you read those, and that'll help you be ready or get ready for this week. Okay, so that's it for this time.